All right, guys, two more questions. Shouldn't be super long questions, but there's a couple things that we're going to pull out of these two questions. The first is, how do we handle if we get this instructions of give all solutions, okay? Not just giving the solutions in the first revolution, 0 to 2 pi, but what if I want all solutions? That's going to be an easy fix. The second one is, how do I handle that calculator piece with arcsine, arc cosine, arc tangent when I want to work in radians instead? All right, so let's work on this one. We want to solve 2 times the sine of x minus 1 equals 0, and we want to give all solutions. This one's pretty simple. We're just going to add 1. We are going to divide by 2. We get the sine of x equal to 1/2. Just like before, we're going to say x equals, well, where does the sine of x equal 1/2? Oh, lost my, there it is. Well, the sine equals 1/2 at pi over 6 and at 5 pi over 6. Okay. All right, so those are our two solutions in our first revolution. However, if we were to look at the graph of this, two sine of x minus 1, and we want to know where this is equal to 0. We see it, oh, we got to switch back here. I'm still in degree mode from last time. Let's go back to radians. Woo. And let's just go, I don't know, 0 out to 10. I'll just zoom out from there. Okay, so here's our first solution, pi over 6. Here's our next one at 5 pi over 6. Where is the next time it's equal to 0? At 13 pi over 6. Now, how do we get that from either of these two answers? Well, we should notice that pi over 6 plus 2 pi would get us to 13 pi over 6. This distance between there and there is 2 pi. If we go back to the unit circle, we hit it at pi over 6. Where's the next time we're in the same spot? Pi over 6 plus another 2 pi. So we're just giving the coterminal angles. Okay. Same with this one. 17 pi over 6 is 5 pi over 6 plus 2 pi. So what we end up doing, let's get back out there. There we go. Is we take our first one, and we add 2 pi, and we add 2 pi, and we add 2 pi, and so on. Then we take our other solution, we add 2 pi, we add 2 pi, and so on. If we look at the period of this function, the period is 2 pi. Okay. So what we can do is we can say, well, it's going to be pi over 6 plus 2 pi k, where k is an element of the integers. And it's 5 pi over 6 plus 2 pi k, where k is an element of the integers. Okay, and we're familiar with that notation. That's all we have to do. Pretty simple. Now, what if, okay, posing another problem here, what if that was a 2x instead? Well, instead of our period, oh, I lost it here. Instead of our period being 2 pi, our period would have been pi, and then we would have just done pi over 6 plus pi k, where k is an integer. So just take a peek at what the period of the function is and just add multiples of that period. Pretty simple. All right, let's go to the next one. 4 sine of x minus 5 equals the sine of x minus 3. For this one, I am going to subtract the sine of x on both sides. Now, these are like terms. We have 4 sines minus 1 sine is 3 times the sine of x. Let's add 5 on both sides. Three sine of x equals 2. Dividing by 3, the sine of x equals 2/3. So where does the sine of x equals 2/3? And we've run into the problem again where that's not on our unit circle. So we say, all right, it's not in my unit circle. I'm not afraid. I can just take the arc sine of 2/3. Now, we did this before. First off, we have to ask, is 2/3 actually in the domain of arc sine? Is 2/3 in the range of sine? And the answer to that, of course, is yes. Okay. So we're going to go to my calculator. But instead of doing this one in degrees like I did on the previous problem where we had to use our calculator to get our solutions, let's do this in radians. So I'm going to switch my mode back to radians. And I am going to type in the arc sine or inverse sine of 2/3. And I get x is about 0.73. Now that is in radians. Okay. Now to just give me a little bit of reference, pi radians is 3.14. Pi over 2 is half of that, which is about 1.57. So if I'm at 0.73, I am in the first quadrant, right? Pi over 2 would be 1.57. 0.73 happens before that. So let's see if we can't find the other place where the sine is equal to 2/3. So here's my unit circle. There we go. And remember that this is up at 1, that's at -1. So if we're wondering where the sine is equal to 2/3, 2/3 is about there on the y values. Remember, sine is y values. So it's equal, the sine of x is equal to 2/3 about here in the first quadrant, and that's the solution that we got from our calculator, 0.73 radians. Where else is it equal to 2/3? Same y value happens right here. So how do we get that angle from here to there? Well, using symmetry, I know this angle is 0.73. Now remember, this is pi. So it's pi all the way to there, but we have to subtract 0.73. So or pi minus 0.73, which is about 2.41 radians. So that's how I handle it in radians instead. Instead of using 180, I use pi. And I just know that my angles here in radians aren't super nice numbers. They're like numbers like 0.73 radians. That's okay. We can handle that. Now remember, we're trying to give all solutions. Okay? So how do we change these to all solutions? Well, we have the two solutions that we know worked. What's the period of this function? Well, we have just x's here, so the period's 2 pi. So we're going to say plus 2 pi k, where k is an element of the integers, and plus 2 pi k, where k is an element of the integers. All right, so that's how we handle that using our calculator in radians when it doesn't work out to be a great angle. That's how we give all solutions. All right, we'll see you later. Thanks for watching.